Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss probability. In this chapter, we are going to discuss the concepts of exercise 16.1. Okay, my children. In the previous class, we have discussed the concepts of hyperbola and we have discussed some questions on hyperbola. I hope you have understood the concepts of hyperbola well, and I hope you have learned the sums related to hyperbola. Haven't you, my dear children? Right. Now come to the exercise 16.1 concepts. Okay, my dear children, are you ready to listen the class? Right. Now come to the introduction. Okay, my dear children. In earlier classes, you have studied about the concept of probability as measure of uncertainty of various phenomenon. We have obtained the probability of getting an even number in throwing a die as 3 by 6, that is 1 by 2. Here the total possible outcomes are 1, 2, 3, 4, 5 and 6. Yes or no, children? The outcomes in favor of the event of getting an even number are 2, 4, 6. That is 3 in number, 3 possible outcomes, favorable outcomes. In general, to obtain the probability of an event, we find the ratio of the number of outcomes favorable to the event to the total number of equally likely outcomes. This theory of probability is known as classical theory of probability. Okay, my children, in earlier classes, whatever you have learned about probability, that is called classical theory of probability. Okay, my children, understood this point? Right. In class 9, we have learned to find the probability on the basis of observations and collected data. Yes or no, my children? Do you remember that point? This is called statistical approach of probability. Okay, my children, in 9th class, we have found the probability of some events which are based on observations and collection of data. This is called statistical approach of probability. And the previous one is classical theory of probability, and this is statistical approach of probability. Okay, my children, understood these 2 points? Right. Both the theories have some serious difficulties. For instance, these theories cannot be applied to the activities or experiments which have infinite number of outcomes. In classical theory, we assume all the outcomes to be equally likely. Yes or no, children? Recall that the outcomes are called equally likely when we have no reason to believe that one is more likely to occur than the other. In other words, we assume that all outcomes have equal chance to occur. Thus, to define probability, we used equally likely or equally probable outcomes. This is logically not a correct definition. Thus, another theory of probability was developed by A.N. Kolmogorov in 1933. He laid down some axioms to interpret probability in his book Foundation of Probability, published in 1933. In this chapter, we will study about this approach called axiomatic approach of probability. To understand this approach, we must know about few basic terms which random experiment, sample space, events, etc. Let us learn about these all in what follows next. Okay, my children, this is the third type of probability. This is called axiomatic approach of probability. In this chapter, we are going to discuss the probability in the axiomatic approach. Okay, my children. So there are three types of probability. First one is classical theory of probability, and second one is statistical approach of probability. And now we are going to discuss axiomatic approach of probability. This axiomatic approach of probability was developed by this Russian mathematician Kolmogorov. Okay, my children, he was born in 1903 and his lifetime is 1987, 1903 to 1987. Okay, my children, understood these points? Right. So now let us discuss the first basic term of this axiomatic approach of probability, that is random experiments. Which experiments are said to be random experiments? In our day-to-day life, we perform many activities which have a fixed result no matter any number of times they are repeated. For example, given any triangle, without knowing the three angles, we can definitely say that the sum of measure of angles is 180 degrees. Yes, sir, my children. In our day-to-day life, we perform many activities. We have a fixed result no matter how many times we have performed that activity, how many times we repeated. So for example, we have taken an example. In any triangle, we know that the sum of the angles is always 180 degrees. As I mentioned, the angles may be different in triangles, but on the whole, finally we get the sum of the all the angles in a triangle is 180 degrees. Yes, sir, children, understood this point? Right. We also perform many experimental activities where the result may not be same when they are repeated under identically conditions. For example, when a coin is tossed, it may turn up a head or a tail, but we are not sure which one of these results will actually be obtained. Such experiments are called random experiments. Understood this difference, my dear children? A random experiment means we know the outcomes of the experiment, but we are not sure which one of the outcomes will actually obtain in that particular experiment. That kind of experiments are called random experiments. For example, if you toss a coin, we know that the outcomes may be either head or tail. These are said to be outcomes, but we are not sure that if a coin is tossed at that experiment we get a head only or we get a tail only. Yes or no, my children? So this is an example of random experiment. Understood this point, my children? Right. An experiment is called random experiment if it satisfies the following two conditions. Okay, my children. An experiment is said to be random experiment. Here we are defining a random experiment. Which experiment is said to be random experiment? That the experiment should satisfy the given following two conditions. Okay, my children, let us see what are the two conditions. First condition, it has more than one possible outcome. Okay, my children, this is the first condition. In that experiment, there should be more than one possible outcome. In the previous experiment, tossing a coin, how many possible outcomes are there? Head and tail, two outcomes. Yes or no, my children? So that first condition is satisfied. And second condition, it is not possible to predict the outcome in advance. Yes or no, my children? In this experiment, tossing a coin, we cannot predict in advance which outcome is obtained in that experiment. Yes or no, my children? So tossing a coin is said to be a random experiment. Understood this point, my children? Right. Check whether the experiment of tossing a die is random or not. Yes. Is it random or not? Is the experiment of tossing a die? Yes. Because in throwing a die, in tossing a die, do you know the possible outcomes? What are the possible outcomes? Whether we get 1 or 2 or 3 or 4 or 5 or 6. Yes or no, my children? These are possible outcomes. So the first condition is satisfied. In tossing a die, we have more than one possible outcomes. And the second one, can we predict the outcome in advance in tossing a die? No, we can't predict which number comes up, which number shows up on the die. Can you predict it in advance? No. So tossing a die is another example of random experiment. Understood this point, my children? Right. In this chapter, we shall refer the random experiment by experiment only, unless stated otherwise. Hereafter, we use the term experiment only. Experiment means here random experiment only. Okay, my children. Both denotes here same. They are not different. Understood this point, my children? Right. Now, come to the some other basic points in this axiomatic approach of probability. Those are outcomes, sample space, and a sample point. In the previous slide, we have discussed random experiment. That is one of the basic points, basic terms. Okay, my dear children, related to approach, axiomatic approach of probability. These are also basic terms related to axiomatic approach of probability. Okay, my children. Now let us define each and every basic term one by one. Okay, my children. Right. A possible result of a random experiment is called its outcome. Okay, my children. Understood this definition of an outcome? Yes. A possible result of a random experiment is called its outcome. Consider the experiment of rolling a die. The outcomes of this experiment are 1 or 2 or 3 or 4 or 5 or 6. If we are interested in the number of dots on the upper face of the die, yes or no, my children? If you consider an experiment of rolling a die, then what are the outcomes in this experiment in rolling a die? Yes, 1, 2, 3, 4, 5 or 6. If you are interested in the number of dots on the upper face of the die. Understood this point, my children? Understood what is meant by outcome of an random experiment? Right. The set of outcomes, set 1, 2, 3, 4, 5, 6, is called the sample space of the experiment. Understood this point, my children? What is meant by sample space? The set of all possible outcomes, the set of all possible results of a random experiment is said to be sample space. Understood this basic term, my children? Right. Thus, the set of all possible outcomes of a random experiment is called the sample space associated with the experiment. Sample space is denoted by the symbol capital letter S. Hereafter, we denote capital letter S to denote the sample space associated with the experiment. Hereafter, remember this point, my dear children, the capital letter S denotes a sample space associated with the random experiment. Understood this point, my children? Right. Each element of the sample space is called a sample point. In other words, Each outcome of a random experiment is also called sample point. Understood this point, my children? Sample point. What is meant by sample point? Each element of the sample space is called a sample point. For example, in this example, in this sample space, 1, 2, 3, 4, 5, and 6, these are called sample points. Understood this point, my children? Right. Now, come to the example. Let us understand these concepts well by taking some examples. What is meant by a random experiment? What is meant by outcomes of a random experiment? What is a sample space of a random experiment? And what are the sample points of a random experiment? All these 4 points. Okay, my children, let us take some examples. Okay, my children, see this first example. Two coins, a 1 rupee coin and a 2 rupee coin are tossed once. Find the sample space. Okay, my children, understood this question? We have to write sample space for this random experiment. In this random experiment, what is done? Two coins are tossed. One coin is a 1 rupee coin and another one is a 2 rupee coin. Okay, my children, for this random experiment, we have to write sample space. What is meant by sample space? Means we have to write all possible outcomes, all possible results of the random experiment. Yes or no, my children? So come to the solution part. Clearly the coins are distinguishable in the sense that we can speak of first coin and the second coin. Yes or no, my children? Since either coin can turn up head or tail, the possible outcomes may be, yes or no, my children? Here on 1 rupee coin also, on 2 rupee coins also, we may get either tail or head. Yes or no, my children? Right. Heads on the both coins, that is head head. Simply we denote by HH. Here head head denote first on the first coin head and the second coin also showing head up. Understood this step, my children? Right. Next, head on the first coin and tail on the other. It is denoted by ordered pair H comma T, and simply we can write HT. Here this outcome denotes on the first head, on the first coin it is showing head and the second coin tail is coming up. Understood this outcome, my children? Right. This is the second outcome. Next, third, tail on the first coin and head on the second coin. It is denoted by ordered pair T comma H, means on the first coin tail comes up and on the second coin head comes up. It is denoted by like this ordered pair, or simply we can write TH. Both denotes same. Both denotes the same outcome. Here also both denotes same outcome. Ordered pair H comma H and HH denote both denote the same outcome. Similarly here also denote the same outcome. Understood this point, my children? Right. Tail on both coins, that is the tail comma tail, ordered by tail comma tail. Simply we denote it by T, means in the first coin tail comes up and the second coin also tail comes up. How many possible outcomes are there? HH, HT, TH, TT. Yes or no, my children? Any other possible outcomes are there in this random experiment, my children? Can you find? No. Thus, the sample space is capital letter S is equal to set of HH, HT, TH, TT. These are possible outcomes. Yes or no, my children? So these are the sample space. This is the sample space. Understood this statement, children? Right. Note, the outcomes of this experiment are ordered pairs of H and T. For the sake of simplicity, the commas are omitted from the ordered pairs. Understood this point, my children? We have omitted, we ignored comma in this ordered pair. We ignored comma and we ignored small brackets also. Simply we wrote HH. In this case of this outcome, simply we wrote HT. We ignored comma and also small brackets. Here also we ignored the small brackets as well as comma. Simply we wrote TH. In this case also, in this outcome also. Understood this point, my children? Right. Now come to the second example. Let us take another example. Find the sample space associated with the experiment of rolling a pair of dice. One is blue and the other red. Also find the number of elements of this sample space. Understood this question, my children? In this random experiment, what is done here? A pair of dice were rolled. One is in blue color and another one is in red color. Okay, my children. For this random experiment, we had to write a sample space and also we had to find the number of elements in the sample space. Number of elements means number of outcomes, number of sample points in the sample space. Understood this point, my children? Right. Now come to the solution part. Suppose 1 appears on blue die and 2 on the red die. We denote this outcome by an ordered pair 1, 2. Similarly, if 3 appears on blue die and 5 on red, the outcome is denoted by ordered pair 3, 5. Understood these outcomes, my children? For our convenient, we are denoting these outcomes like this in the form of ordered pair. If a blue die shows up 1 and red die shows 2 up, then we denote it by ordered pair 1, 2. Similarly, in this outcome, if 3 appears on blue die and 5 appears on the red die, then we denote that outcome by ordered pair 3, 5. Understood this point, my children? Right. In general, each outcome can be denoted by the ordered pair x, y, where x is the number appeared on the blue die and y is the number appeared on the red die. Okay, my children. For our convenient, we are writing the outcomes in the general form. Here, x denotes the number appeared on the blue die and second number y denotes the number appeared on the red die. Understood this point, my children? Right. Therefore, this sample space is given by capital letter S is equal to set of all ordered pairs x, y such that x is a number on the blue die and y is the number on the red die. Understood this sample space, my children? We wrote the sample space in the set builder form. Do you remember that point, my children? In the first chapter, set theory, we wrote a set in the set builder form and we can write it in the roster form. Yes or no, my children? Here, sample space is also a set. So we represented this set in the set builder form. Okay, my children? Understood this point? Right. The number of elements of this sample space is 6 into 6, that is called 36, and the sample space is given by below. Here in this random experiment, total possible results are 36. Okay, my children. Here we used the concept of permutations. On the first die, 6 possible outcomes, and on the second die, how many possible outcomes? 6. So on the whole, the total number of outcomes can be found by using the multiplication rule. In the permutations, have you remembered that point, my children? Do you remember that point? Yes. So 6 into 6, total 36 outcomes in that sample space. Now let us write the sample points in that sample space. Okay, my children. Set of ordered pair 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6. 2 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. Okay, my children. Understood these outcomes. And 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6, 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5, 4 comma 6. Understood these outcomes also, my dear children? Right. Similarly, 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4, 5 comma 5, 5 comma 6, 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5, and 6 comma 6. If you count all these sample points, these are all said to be sample points in this sample space. How many sample points are there? Total 36. Understood this example, my dear children? Right. Now let us take another example. Okay, my dear children. In each of the following experiments, specify appropriate sample space. Here also, in this example also, we have to find the sample space of the random experiment. Okay, my dear children. Right. The first random experiment. A boy has a 1 rupee coin, a 2 rupee coin, and a 5 rupee coin in his pocket. He takes out two coins out of his pocket, one after the other. This is the first random experiment. Okay, my children. A boy has three kinds of coins. One is 1 rupee coin, and another one is 2 rupee coin, and the third one is 5 rupee coin. But he is taking out only two coins out of his pocket, one after the other. Then for this random experiment, we have to write the sample space. Understood this question, my children? Right. Now come to the second experiment. A person is noting down the number of accidents along a busy highway during a year. This is another experiment. For this experiment also, we have to write appropriate sample space. Understood this question, my children? Right. Now come to the solution part. Let Q denote a 1 rupee coin, H denote 2 rupee coin, and R denotes a 5 rupee coin. The first coin he takes out of his pocket may be any one of the three coins, Q, H, or capital R. Corresponding to Q, the second draw may be H or R. So the result of two draws may be QH or QR. Similarly, corresponding to H, the second draw may be QRR. Understood this outcomes, my children? For our convenient, we are denoting if that boy takes out 1 rupee coin, then it is denoted by Q. And if he takes out 2 rupee coin, then it is denoted by H. If he takes out 5 rupee coin from his pocket, then it is denoted by, that outcome is denoted by capital letter R. Understood these three outcomes, my children? Right. Here he is taking out two coins from his pocket, one after the other. Yes, sir, my children. So first he takes out, he can take any one of these three coins. Yes, sir, my children. Either Q, H, or R. Suppose if that boy takes out first 1 rupee coin, then second draw may be either H or R. Yes, sir, my children. Then in this case, the outcomes may be QH or QR. Yes or no, my children? Similarly, if he takes out first 2 rupee coin, means H, then the second draw may be either Q or R. Yes or no, my children? Therefore, the outcomes may be HQ or HR. Lastly, corresponding to capital R, the second draw may be H or Q. Understood this point, my children? Right. So the outcomes may be RH or RQ. Understood all these outcomes, my dear children? Right. Thus, the sample space is capital letter S is equal to QH, comma QR, comma HQ, comma HR, comma RH, comma RQ. Understood this sample space, my dear children? We have found all the outcomes. Total 6 outcomes are possible. So we have written all the 6 outcomes. These are also called sample points. Understood this point, my children? Right. Now come to the second experiment. Here a person is noting down the number of accidents along a busy highway during a year. So the number of accidents along a busy highway during a year of observation can be either 0 for no accident, or 1 or 2 or some other positive number. As for my children, the accident may not occur, or one accident may occur, or 2 accidents, or some other positive integer number of accidents. As for my children, right. Thus, a sample space associated with this experiment is capital letter S is equal to set of 0, 1, 2, and so on. Understood this sample space, my children, for this random experiment? Right. Now let us take another example. A coin is tossed. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white balls. If it shows tail, we throw a die. Describe the sample space of this experiment. Understood this question, my children? If we here first a coin is tossed. If a coin is tossed, what are the possible outcomes? Either head or tail. Yes or no, my children? Yes. If it shows head, we have to draw a ball from a bag consisting of 3 blue and 4 white balls. We have to draw only one ball from this bag, but in this bag 3 blue balls and 4 white balls are there. If it shows tail, we throw a die. Understood this random experiment, my children? So for this random experiment, we have to write sample space. Understood this question, my children? Right. Now come to the solution part. Let us denote blue ball by B1, B2, B3 and the white balls by W1, W2, W3 and W4. Okay, my children, because here 3 blue balls are there and 4 white balls are there in that bag. So for our convenient, we are denoting that balls by B1, B2, B3 for balls and W1, W2, W3 and W4 for 4 white balls. Okay, my children, understood this step? Right. Then a sample space of the experiment is capital letter S is equal to HB1, HB2, HB3, HW1, HW2, HW3, HW4, T1, T2, T3, T4, T5, T6. Understood these outcomes, my dear children? If tails comes, then we are throwing a die. Then we get these outcomes 1, 2, 3, 4, 5, 6. So tail is associated with these 6 numbers, and H is associated with these 7. B1, B2, B3, W1, W2, W3, W4. So we got all the possible outcomes in this random experiment. This is a sample space for this random experiment. Understood this example, my children? Right. Here HBI means head on the coin and ball BI is drawn. HWI means head on the coin and ball WI is drawn. Similarly, TI means tail on the coin and the number I on the die. Okay, my children, understood this experiment and understood this sample space? Right. Now let us take another example. Consider the experiment in which a coin is tossed repeatedly until a head comes up. Describe the sample space. Understood this question, my children? Here also a random experiment was performed. In this random experiment, we had to find sample space. We had to find the sample space of this random experiment. What is the random experiment? A coin is tossed repeatedly until a head comes up. Okay, my children, understood this experiment? Right. Now come to the solution part. In the experiment, head may come up on the first toss or the second toss or the third toss and so on till the head is obtained. Yes or no, my children? We have to toss the coin until head comes up. So in the first trial we get to toss, or the second in the second chance we get in the second toss we may get head, or in the third toss we may get head, and so on. Yes or no, my children? Right. Hence the described sample space is capital letter S is equal to H comma TH comma TTH comma TTTH comma TTTTH and so on. Understood this point, my children? Here first, if we gets head, we stop the experiment. Suppose in the first toss he get tail, then he has to toss the coin. Then the second toss we got head. Otherwise, first two times tail, then we got third time head. Otherwise, first three tosses. In the first three tosses we got a tail, and on the fourth toss we got a head. Otherwise, in the first four tosses we got a tail only. In the fifth toss we get a head, and so on. Understood all these outcomes, my dear children? This is a sample space for this random experiment. Understood, my dear children? Right.